Hi, this is Rakesh Gupta, and this is my take on question 6 of Interm Video Assessment.
First, I would like to start by talking about what Dirac delta is. Basically, Dirac delta, this is a function, this is a Dirac delta function, a general one. So, this function says that this function it is equal to 0 for t not equal to alpha and is equal to infinity for t equal to alpha. So, if you look at the graph, basically what happens is the graph it is 0. For example, this point is alpha. So the graph is just at 0 until it reaches alpha, and then there is a sudden growth, there is a sudden impulse, you can say, when the when the graph reaches at alpha. So if in the given ODE there is Dirac delta, we come to the question. So there, we can see that there is a Dirac delta function involved. So this means that there is an impulse involved. That means that there is for a long amount of time. So for a long amount of time, there is no change in the graph, but then all of a sudden there is a change. So in this case, that sudden change is at 3 pi. So we can say that this phenomena it could also be said as impulsive nature. So this impulsive nature usually happens when there is a spring block system. So for example, this is a spring and there is a block connected to it. So what happens is if this spring has been stretched out a bit, so if this spring has been stretched out a bit and you suddenly leave the block. So for when you are already holding the block and you have not released the spring yet, so then there is no movement. But then as soon as you release the spring, as soon as you release the block, there is a sudden change. There's a sudden change, right? So that is what I'm calling as impulsive nature. So what I'm predicting is that this the real life phenomena, the A part of the question, the real life phenomena is nothing but a spring block system. So coming to the B part, which is where we have to sketch the graph. So as over here given in the ODE, the Dirac delta function is t minus 3 pi. So t minus 3 pi, it states that there is no change in the graph until 3 pi and then the movement starts. So I would say there is no change in the graph if this is considered to be 3 pi. There's no change in the graph until 3 pi. And as it is a spring block system, so there is supposed to be oscillation occurring. So from 3 pi onwards, oscillation starts. Now this oscillation, it could be damped or not damped. That depends. It should be given in the question. So yeah, this is going to be the graph that till 3 pi there is no movement and then the movement starts, and as it is a spring block system, so the movement is oscillatory. So now coming to the C part. So we can for solving the given ODE, I'm just going to write the ODE down. And the initial conditions are y of 0 is 0 and y dash of 0 is 0. Y of 0 is 0 and so now as similar to the fifth question, we have the formula for the Laplace of a double derivative. So Laplace of y double dash is given by s square into Laplace of y minus s into y naught, y of 0 minus y dash of 0. Also, the Laplace of a Dirac delta function is given by e power minus as, where a is equal to, in this scenario, a will be 3 pi. So now we solve further. So we have the given ODE, right? So we are just going to apply Laplace on both the sides. Sorry. Now we use distribution of Laplace. This is supposed to be an L. So as the Laplace of a Dirac delta function is e power minus as, and over here a is 3 pi. So I'm just going to write this as e power minus 3 pi s. So now we know the formula for this is given over here. I'm going to write this as s square y now also if you see that we have the initial conditions or the conditions given in the question, y of 0 is 0 and y dash of 0 is 0. Hence, this term and this term are going to be 0. So we have s square Laplace of y plus 16 Laplace of y is equal to 4 e power minus 3 pi s. So I take Laplace of y common. So now I write Laplace of y as 4 pi s square plus 16. I'm just cross multiplying. Now I'm going to use inverse Laplace on both the sides. It's going to give y is equal to plus inverse of, so now according to or maybe using second shifting theorem, which says that the Laplace inverse Laplace of f of t is equal to f of s. So over here, we can see that 4 pi s square plus 16, this term is our capital F of s, and the Laplace of sine 4t is nothing but 4 pi s square plus 16. So we can now write this as sine of 4t minus 3 pi multiplied with u of t minus 3 pi. So now our y is given by sine of, we can write this as minus sine of 12 pi minus 4t dot u times t minus 3 pi. Now y is equal to minus sine. We can write this as 12 pi is a multiple of 2 pi. So the cycle is complete. Sorry. So this is so the 12 pi is going to go, and this is going to be sine 4t. The sine of minus x is minus sine x. So the that minus and this minus over here, it gets cancelled out, multiplied with u of t minus 3 pi. So this is our final answer. And coming to the graph of this, it is going to be constant till 3 pi, as I mentioned before, as there's going to be no change till 3 pi, and then a periodic oscillation is going to start. A periodic oscillation of the sine wave is going to start, and as it is sine 4t, so the period of this oscillation will be 2 pi by 4, which is pi by 2. So with a period of pi by 2. Yeah, that's all. Thank you.